Okay, so our big question is, are the two figures similar? And in order for two things to be similar, you guys remember how we checked that last time? If you don't remember, can you get up your notes? We had, this is in your packet, your similarity graphic organizers. I'll get you one next time, sorry. And I'll let you take a picture and copy all this down. You guys remember doing this? Did we put an example in our notes here? Take some notes. Yeah. So how do we tell if six figures are similar? The lengths have to be in proportion, which means your ratios are all equal. So remember with this one, we made a bunch of ratios with all of our sides. Ratios are just fractions. And all of our fractions ended up equaling the same thing. And all the angles have to be congruent. So that's what has to be true in order for the two shapes to be similar. So let's do that for our question. We're going to need a couple more sides. Do you know what the other two lengths of this rectangle are going to be? 6 and 2, right? Because rectangles are the same length on opposite sides. And this would be 21 and 7, right? So there's 4 sides, so we would need to have 4 ratios. Now, technically, we're going to have 2 copies of the same thing. But let's go ahead and write out our 4 ratios. They're fractions. I'm going to get them started here. And it really doesn't matter what order you go in. We can put the small rectangle on top and the big rectangle on the bottom, or we can flip it. It really doesn't matter. We just need to be consistent. So let's choose now, before we get started, which one's going to go on top. Do you want the small rectangle numbers on top or the big rectangle numbers on top? Anybody have a preference? Small or big on top? Small on top. All right, so we're going to go small on top. I'm just making myself a note so I don't mess this up. And big on the bottom. So one of my ratios would be, let's see, 2 and 7 match up. Those are corresponding sides. So one of them would be 2 and 7. Actually, 2 of them would be 2 and 7 because I've got another pair of 2 and 7. And just double checking, making sure I put my small one on the top and the big one on the bottom. We just need to be consistent with that. My other 2 are going to be the same. They're going to be 21 and 6, right? 21 over 6 or 6 over 21? 6. So we said we were going to put the small on the top. So let's stick with our decision here and be consistent. And then we would have another 6 over 21 for the, backwards there. 6 over 21 for the other pair of sides. So the question is, are all 4 of those fractions the same? These 2 are definitely the same. These 2 are the same, but are these the same fraction? If you reduced 6 over 21, what would you get? What can you divide both 6 and 21 by? You could divide them both by 3. 6 divided by 3 is 2. 21 divided by 3 is 7. Yeah, that would come out to be 2 over 7. And so with this one. So are the sides in proportion? Yes, so let's write that down. Sides are in proportion. When we say the sides are in proportion, that means when we made ratios out of all of our sides, we ended up with the exact same fraction for every single pair of sides. Now that's not enough. The other thing we need for similarity is for all of the angles to match up. So these 2 angles are corresponding. They're both 90. These are both 90. These are both 90. These are both 90. Yes. So all angles match. And those 2 things together mean what? Our rectangles are similar. Did I show you guys the symbol for similar? Oh, would you like to know the symbol for similar so you don't have to write out the word every single time? That's the symbol for similar here. It's just a little squiggle, kind of like a tilde. It's kind of like the thing that we put over top of the equal sign when we're doing congruent. All right, so quick review over how to tell if two things are similar. Are we feeling okay with how you can test? Now, the kind of the pain in the neck of these types of problems is as many sides as you have, you're going to have that many angles. And that means you've got to check, like in this case, we had 4 sides. We had to check 8 different things. I had to check 4 different ratios of sides, and I had to check 4 different pairs of angles. So we're mostly going to be doing triangles. And when we start looking at similar triangles, you're going to have to check 6 different things. You have to match 6 different things. So it's kind of tedious. The good news is that next week, and we're going to learn some shortcuts specifically with triangles, where we only have to check 2 or 3 things instead of all 6. That's going to make our job a lot easier figuring out 2 things. All right, so we're going to practice solving for similarity. This is going to be problem 25 in your book. You don't need to open your book just yet. I'll give you a page number and everything. We're going to do one or 2 problems together. So I'm going to do 25A. It's a couple of rectangles again. Making a rough sketch of a couple rectangles. And they gave us some side lengths, 2 and 6, and 4 and X. And we are told in the problem in 25 that figures are similar. All right, so this time we're going to kind of go backwards. We don't have to figure out whether they're similar. They already told us that they're similar. We need to use this to solve for X. So what we did before was we made ratios, and the ratios helped us to show that they were similar. Now they told us they were similar. We're going to use ratios now to solve for X. So this is our main goal for today, is to use ratios to solve for missing sides. So let's set ourselves up a couple of ratios. And I'm putting an equal sign in between them because why? We know that they're similar. And if they're similar, that means the sides are, the vocab again? In proportion. Thank you. The sides are in proportion. That means we should have equal ratios, right? So let's write a couple of ratios. Again, we need to make a choice. We're going to go big on the top or small on the top for this one. Small on top again. And there's no wrong answer to this, just so we're being consistent. So I'm going to match up my sides. 2 and 4 go together, so that'll go in one of my ratios. You said you wanted the smaller one on the top, so I'll put the 2 on the top. My other pair of corresponding sides are the 6 and the X. That's going to be my other fraction. We chose to put the smaller one on the top. We can see from the figure that this is the smaller one. So let's get our 6 on the top and our X on the bottom. I'm going to give you a huge hint right here, okay? Because this is the #1 source of error when we do our test in a few weeks. The biggest mistake people are going to make is when they write these things, they're going to flip one of these fractions, right? It's really easy to do. We could have put X over 6 here instead. So what would you do to keep yourself from making that mistake? What would your strategy be? I'm going to tell you that most of you are going to make that mistake at some point on your homework assignments here or on our in-class assignments in the next few weeks. So what are you going to do to make sure you don't make it on the test? What would be a good strategy? So your strategy is to be consistent. You're just going to always pick the smaller one on the top. So if you're going to train yourself, always do the smaller ones. And you know that it doesn't have to be that way, but you're going to choose to do it that way to avoid making that mistake. I think that's a great strategy. That's awesome. I like that a lot. My strategy is I always just go back and double check. I'll just go back and double check really quickly. I chose to put the small on the top. Is the 2 the smaller of the 2? Yes. Is the 6 the smaller of the 2? Yes. Okay. Now I'm feeling confident about it. So I have been burned by this mistake so many times that I force myself to double check because I don't want to have to go back and do it All right, now that we're confident in this, we just have to do a couple quick steps of algebra to solve. So we'll cross multiply. I'm going to do 2 times x, that's 2x, equals, and then 6 times 4. I probably would, if I were doing this in homework, I would probably just write 24, but I'm writing out every step because this is notes, and that's a good idea to show all of your steps in notes. 6 times 4 is 24. And then we could do a quick step of algebra to get x by itself. Just divide by 2 on both sides. And we got x equals 12. Question?
Could you also do it, where it's the like 2 by whatever factor takes to 6.
I love that. So you're asking, is there another way that we could do this? And that's so my next question was going to be, how could we check this? And a great way to check an answer is to try and do the problem a different way, see if you get the same answer. So I think what you're suggesting is to look at scale factor. Is that what you're talking about? Like if I looked at this 2 and this 4 and I asked myself, what am I doing to get from 2 to 4? What am I multiplying by? What is my scale factor? Times 2, right? So that should be consistent with the 6. I should do 6 times 2, and that should get me to x. And that would get me 12. That would work. So it would be acceptable. I'm going to tell you that it's going to be really rare that it comes out to something as simple as 2. You're going to see a lot of these where x is going to end up being a fraction, where your scale factor will be something like 5/12 or something like that. So I think for me, my safest bet is to set up a proportion. We're also going to see some problems where it's not just x. This might turn into like 3x minus 4. And in that case, this is probably going to be more trouble than it's worth. So can you do it this way? Yes, you can. And I think it's a great way to check. But I would recommend that you're really comfortable doing it this way too, because sometimes this is definitely the easier way to go. Does that make sense? All right. So yeah, a lot of you are probably looking at this and saying, "Oh, I could have told you that was 12 before we even got started," and that's great. Make sure you can set up a proportion and solve it too. All right, let's look at part B. For this one, let's go ahead. I do want you to have a look at what this picture looks like in your textbook. This is on page 156. Could you please open up your book and have a look at that? I'll put it up on the screen too, but I want you to be able to see it in front of you. All right, so this kind of leads me to another really important strategy that I want to show you guys. And some of you are going to think this is probably overkill for a problem like this, but it is going to become important with some problems later on. So just stick with me on this. I'm going to sketch this. Don't start drawing this yet, but don't start drawing it. I'm going to draw this figure, sketch this on your paper, just the one on the left. So just sketch that one on the left first. It's a weird looking, how many sides is that? 5 sides, that's a pentagon. Kind of an interesting looking pentagon. It has an X here and a 4 here, and they've marked a couple of 90-degree angles. I don't think that's important, but we'll go ahead and draw them. All right, so before I draw the other one, I'm going to show you a strategy that's going to be really helpful to you. So notice how this second shape is not facing the same direction as the first one. It's not orientated the same way. When I draw this second shape on my paper, I'm going to flip it around so it looks like this. So everything's facing in the same direction. Okay, and this is you're going to want to do this because you're going to run into some more complicated shapes where they're going to try and trick you into matching things up the wrong way. So I want this to look like this. So basically, I want to draw it like this. I just flipped my book upside down. So I'm going to redraw that second one, but I'm going to draw it so that it's in the same orientation as the first. This is going to make it easier for me to accurately get things matched up properly. So instead of drawing them exactly as they were in the book, I'm going to rotate this and orientate it a little bit differently. Okay. Again, we're told that they are similar, so we should be able to set up a proportion. And solve. Go ahead and set your proportion up however you'd like. Remember, it's a smart move to decide ahead of time whether you're going to go with the bigger or the smaller number on top, and then be consistent with that. Do you need some paper? Okay. Go ahead and write and solve a proportion for me. Put it away. All right, did anybody write the same proportion that I did there? I better double check and make sure this is right. When I did this one, X and 6 definitely match up, so that's good. I chose to put the bigger one on top and the smaller one on the bottom this time. And then when I did the 3 and 4, I messed up. I went bigger, smaller here, but then I went smaller, bigger here. This is not going to work. If I solve this, I'm going to get a wrong answer. So you decide whether I did that on purpose or not. But it's really good to check your answers. So let me be consistent. So I went bigger over smaller. So I want to go bigger over smaller again. I'm going to do 4 over 3. Did anybody flip these and do 6 over x equals 3 over 4? Anybody do it that way? That works also. Now there are some other ways to do this. Did anybody go 4 over x equals 3 over 6? That is actually going to work because I am being consistent. Now the 4 and the x are in the same shape, but they're the same sides as the 3 and the 6. Okay, so this is going to work. This is going to work. In fact, just to convince you, if I were to cross multiply here, I would get 3x equals 24, right? And if I were to cross multiply here, I would get 3x equals 24, right? I could also go, I could have done, instead I could have done x over 4, right? X over 4. And if I were going to do x over 4, what would I need to put in my second fraction to make it consistent? X over 4, I would need to do 6 over 3. That would work also. It turns out as long as you're being consistent about how you write your fractions, you're going to get an equation you can solve. Again, if I cross multiplied any one of these, I'm going to get the same next step, 3x equals 24. It will, yeah. So I think for me, I prefer to do it like this. I prefer to have matching sides in one fraction. Matching sides in one fraction. But some of my students find it makes more sense to them to go 2 sides from the same shape in one fraction, 2 sides from the same shape in the other fraction, and just be consistent about how you label those sides. All right, so no matter what we do, we're going to get 3x equals 24. Let's do our last step here. Divide by 3 on both sides. We'll get x equals 8. All right, any questions on B? How could I check this? I've been really big on trying to get you guys to check your answer. What could you do really quickly to check? Yeah, we could check our fractions really quick, right? I could go 6/8 and 3/4. And are those the same fraction? Yes. Yeah. Right. If I had a calculator, I could type in 6/8, get a decimal, type in 3/4. If I get the same decimal, then I'm good to go. Cole, can you put your phone away, please? Go ahead and put that computer away too. Less distractions. All right, we got C to do still. C is kind of tricky. Go ahead and sketch it for me, please. I'll draw it up here if you close your book. Couple rectangles again. And in the picture, they put in the book they put 90-degree angles in here, so we did know they were both rectangles. And remember in the instruction, they told us that they were similar, so they've got to have the same shape. The sides need to be in proportion. The trouble with this one is I don't have enough information to set up a proportion. I'm missing the side that matches up with the 3. Now, what other sides do I know in this rectangle? We know the bottom is, right? We know the bottom is 21. And if I were to add up all 4 of the sides, what am I going to get? 60. That's what the perimeter is, right? So how much are we missing here? I got 21 and 21. That means I'm using up 42 out of 60. This is 42, right? How many more do I need to get up to 60? 42 plus 18 is 60, right? So that means these two sides must add up to 18, and they got to be the same. So 9 and 9. Now, before you write a proportion and solve, I want you to think through. Jackson kind of gave us a hint about a kind of a quicker way we could think about these problems. What would our scale factor be to go from this rectangle to this rectangle? Well, it's pretty easy for us to see now, right? We would go times 3 to get from here to here. So what would I need to multiply by 3 to get 21? I think x is going to be 7, right? Let's go ahead and practice, though, writing a proportion and solving. So whatever your favorite way from the 4 different options I just showed you, go ahead and set me up a proportion. I'm going to go with matching sides because that's what I feel most comfortable with. So I'm going to do x and 21 in one fraction. And 3 and 9 are corresponding sides. And I did x on the top. X is smaller, so I want to do 3 on the top this time. And I'm going to force myself to double check to make sure I didn't flip anything around because I've made that mistake so many times. 3 and 9 match, x and 21 match. So I got my fraction set up right. Did I do the right thing in the top? I chose smaller shape over larger shape for this fraction. I got smaller shape over larger shape for this fraction too. So I'm being consistent. Should be good to go here. Cross multiplying x times 9 is 9x. 21 times 3 is 63. And one quick step of algebra, we should have x. We think it is going to be 7. Is that what 63 divided by 9 is? Hooray! All right, what questions do you have? We're about to practice some of these. So I'm going to ask you guys to flip to page sorry, 162, page 162. And we're going to do number 38. And I'll tell you what, just do part A for me right now. Take a moment right now and do part A. Notice that in part A that the two rectangles are not orientated the same way. So make sure that when you draw them, you spin one of them so that it's facing the same way. You can either make them both standing up tall and skinny like this one, or you can make them both short and wide like this one. But make them so they're facing the same direction. This is on page 162. This is number 38. I just want you to do part A right now. Please do not start on part B just yet. Page 162, yes. Number 38, just part A. Double checking. X and 12 match, 6 and 9 match. X is bigger, 12 is smaller. 6. Oh, that's no good. So now they got those flipped. Pause for a second wherever you are. Look up here. Some of you might be finished already. I want you to check your proportion. Yours might look different from mine, but check something for me. Do you either have 12 and X in the same fraction, but if they're not in the fraction, then they should either both be on the top or both be on the bottom? Are 12 and X matching up either in the same fraction or both on the top or both on the bottom? Same with 6 and 9, either both in the same fraction or both on the top, both on the bottom? Do you have X and 9 either in the same fraction or both on the top and both on the bottom? Do you have 12 and 6 either in the same fraction or both on the top and both on the bottom? So as long as you've got those, there's 4 different ways we can write this thing. But as long as you're matching up, the 12 and the x are either on top of each other or across from each other. As long as the 9 and 6 are either on top of each other or across from each other. And same with the x and the 9 and the 12 and the 6. You should be good to go. All right. So let's do this. 6 times x is 6x equals 9 times 12 is 108. And then we can divide by 6 on both sides to get x equals, oh, let's see here. 18 sound right? No, that's not right. Is it? 18? Okay. 18. I don't know why, but I don't feel that doesn't seem right to me. You think it's 18, huh? Usually, okay. I'm going to double check because I just like to know for sure. I'm going to go ahead and write my two fractions, 6 over 9 and 12 over 18. 6 over 9, 12 over 18. Thank you. And because I'm feeling a little lazy, I'm gonna grab my calculator and just divide these two things and see if I get the same decimal for both. So 6 divided by 9 is 0.666 repeating. 12 divided by 18 is, oh, the exact same thing. Okay, good. Then it must be the right answer. I've checked and I've checked my ratios and they do come out to be equal to the same thing, the same decimal. So we're good. All right. Show me on your thumb meters how you feeling about setting up and solving these equations. Are we feeling pretty good about them? Okay, but do we all recognize it's really easy to flip one of these fractions and get a wrong answer? You gotta train yourself to double check. I actually I don't know if you guys were watching, but I made a mistake here. Can you see the whiteout tape? And I wouldn't have caught it if I hadn't double checked. We're gonna backtrack a little bit. Flip one page back. This is on page 161. And I want us to look at number 37. So this is a really important problem because we're going to introduce something called a similarity statement. Let's go ahead and write that down. Most of you are going to find that this is going to be one of the easiest things that we do in this entire chapter. However, that said, every year my students miss really easy points on their tests on the similarity statement questions. Because it's one of those things you got to be really meticulous and careful. If you rush it, you don't double check, you're going to get a wrong answer. But it's actually very, very easy to do. All right, so let's go ahead and draw the first two triangles, the ABC and the CYX. They both look like they're right triangles. In fact, they're marked as right triangles. And I need you to actually write the letters in this time. Make sure you got those two triangles drawn. They did tell us in the instructions that they're similar. I'm going to put that little squiggle in there to remind myself that they are similar. They didn't give us enough information to test it yet because we don't have any sides to write fractions with, right? But they told us they're similar, which means that we should be able to write a similarity statement. And we're actually going to write at least 3 here, okay? So I'll show you what a similarity statement looks like. It's going to say triangle something is similar to triangle something. We got options here. So I'm going to make this my first triangle. When we name a triangle, we have to give the letters of the three vertices. So I need 3 letters after this triangle symbol. And we're going to go with these 3 letters here. Any order that you want. So who would like to give us our order for the first one? Max, what do you want? You want to go A, B, C? Let's keep it alphabetical here. So I'm going A, B, C for the first one. Now, once you do the first one, then the second one is where you got to be careful. Remember a moment ago I said this is really easy to do, but it's also really easy to mess up. I need to set the next 3 letters, and they've got to be X, Y, and Z, but I need to get them in the right order so that it matches the same order that I did in the first one. Do you get what I'm saying? So focus your attention on angle A, because that's what I had first. What is our vertex in the second triangle that matches up with angle? Angle Z matches up with it. So Z must come first in the second one because it matches with the first one in my first triangle. You know how that works? All right, and then I'm going to look at B. B was second here. B was my 90-degree angle on this triangle. What matches up with that in my other triangle? X matches up. So B came second here. X has to come second here. And then finally, well, by process of elimination, it has to be Y, but we can just double check and make sure that it does match up. C does match up with Y. So B matched up with X and C matched up with Y. And so we've got a proper similarity statement. So a second ago, I told you that most people are going to find this pretty easy. This looks pretty easy, right? All you got to do is match up the 3 letters. The first one can be in any order that you want. The second one just has to be in a matching order, right? But can you see how it'd be really easy to flip a couple of these if you weren't careful? Usually, the question was, could it be with numbers too? Usually, we're going to name them with letters. We're going to name them with capital letters because these represent points. We are going to see kind of corresponding numbers pop up later on. So something kind of like that. But when we're doing a similarity statement, we're going to be using letters, capital letters specifically. Now, is this the only correct similarity statement for these 2 triangles? No, because I didn't have to do A, B, C. I could have picked a different order on this first one. In fact, let's do a different order. Let's do triangle, I don't know, let's do BAC. Write me a similarity statement for triangle BAC instead. It's still going to have an X and a Y and a Z in it, but you just need to make sure they get in the right order. So be very careful. Go 1 letter at a time. What matches up with B, and then what matches up with A, and then what matches up with C, and get it in the same order for your second triangle. So B was the 90-degree angle. I'm going to match B up with X. A was the single tick angle. That's going to match up with Z. C was the small double tick angle. That matches up with Y. X, Z, Y would be the proper one. Okay, pretty basic, but I'm going to tell you that if you're not really careful with these, and if you don't practice being careful with them in your homework, there's a really good chance you're going to miss out on some easy points on your test. Okay, every year, I'm always surprised that I have a lot of people that get these wrong just because they go too quick. All right, can you show me on your thumb meters how you're feeling about writing a similarity statement? Okay, so it sounds like we're understanding the concept. Okay, that said, I've told you enough times now that people make mistakes. Do you feel sufficiently warned, and are you going to check your answers really carefully on this? All right, so let's look at a slightly more difficult one. So I'm going to draw the one that's down below this. It's got dog and cat. Oh, this is a classic problem. The dog and cat problem. 8, 9, 5 D O G. Oh, thank you for fixing that for me. Now, they did not tell us that these two triangles were similar, so I want to test to make sure that our proportions all work here. So I'm going to go ahead and write myself 3 fractions and make sure those fractions all end up being the same thing. Now, this is a little tricky here. So be careful. My recommendation is when you've got 2 triangles and you're not 100% sure what matches up with which, start with your biggest 2 sides, and then your smallest 2 sides, and then your medium 2 sides. What I mean is, when I look at these 2 triangles, the 9 is biggest here and the 18 is biggest here. Those should match up. I'm going to go 18 over 9, which is 2. So 18 matches up with 9. What does the 8 match up? I'm sorry, what does the 5 match up with? How do you know the 5 matches up with the 10? Ooh, look at you talking about transformations. So if I reflected this one, it would match up on top of that. So you're able to visualize that. You must be a strong visual thinker. Some people aren't going to be able to so easily kind of mentally do a reflection. So what would be my other clue that 10 and 5 are going to be corresponding? It is 5 is the shortest side in this triangle, isn't it? And 10 is the shortest side in this triangle. So that's my other clue. They match up because they're both the shortest sides in the triangles. 10 and 5 match up. I'm going to go bigger over smaller, 10 over 5. And that also comes out to be 2. And then my remaining sides are 16 and 8. And lo and behold, those also end up equaling 2. So the sides are in proportion. We don't know anything about the angles, but I'll just go ahead and tell you the angles all match. So they are similar. So it's time to write ourselves a similarity statement. So you guys ready? This is where it gets tricky. Remember, this is an easy concept, but it's easy to make mistakes. I'm going to call this first one triangle dog, right? Why don't we try it? Triangle dog is similar to triangle. All right, now this gets tricky. Be careful. Be careful. Is it going to be cat? You want it to be cat, don't you? This is a classic geometry problem. You want it to be cat, but we got to make sure that it's not cat. So what we need to do is we need to figure out what matches, and it's tricky sometimes to tell. Now this one, they've got it drawn in a way that makes it a little bit easier, but sometimes they're going to be drawn in a way that they all look like they're the same sides. So how are you going to tell? So here's my trick. I'm going to show you one of the things. I actually stole this from a student in the past. Okay, I'm going to do dog. I'm going to look at D, and I'm going to notice that D is across from the smallest side in that triangle. Agreed? D is across from the smallest side. And the smallest side in this triangle is 10. And what's across from the 10 is C. So C has to match up with D because those are the angles that are across from the biggest side. I always look at what they're across from. And then I would look at my O. I'm going to notice that O is across from the biggest side of the triangle. So I want to go and find the biggest side in this triangle, which is 18. And I'm going to match that 18. It's across from the T. So O is going to match up with T. And then whatever I got left over has to be the last one. So I've used the C and the T. It must be A. And I could just double check. A is across from the medium size. G is across from the medium size also. So CTA would be matching up with DOG. I want you to try one more for me. Triangle, I'm going to call this, instead of dog, I'm going to call it OGD. Can you write my similarity statement if I'd chosen to go OGD first? So O is across from the biggest. I'm going to go across from the biggest. G is across from the middle size. I'm going to go across from the middle size. And then D is across from the smallest, across from the smallest. Did you get cat? I was hoping it'd come out to be cat. What would I need to have to match up with cat?
No.
Now I could look at this one and just flip the letters around, right? If this is correct, then all I'm doing is flipping the first and last. So I should be able to just flip the first and last here. DGO, maybe? Double check and make sure that works. D is across from the smallest. C is also across from the smallest. G is across from the medium. A is also across from the medium. O is across from the biggest. T is also across from the biggest. We're good. Okay. Can I get a thumb meter read on this again? I'm expecting this might have gone down a little bit. You guys, or some of you are starting to see where this can get a little bit tricky, right? You just got to be really, really careful. All right. So now let's go back to page 162 and finish up the rest of number 38. So next page over, number 38. We already did part A. Let's look at part B here. And sketch them. And this time around, I want you to write down the similarity statement. Excuse me. And I need to write down my similarity statement. Sorry. Triangle, nope, is similar to triangle axes. I'm going to show you a couple strategies for this. Now, so the tricky thing here is it's hard to tell what matches up with what. So when I get to try and write my proportion, I know I'm going to have W somewhere in my proportion. The question is, what goes underneath the W? What goes with the W? Is it the 3, the 4, or the 5? How do you know? Because they're both on the bottom? All right, that's not always going to work. Be careful of that. It's not always going to work. So what you want to do, remember how we were talking about across froms before? Focus on this W and what side or what angle is it across from? What vertex is it? It's across from the X, isn't it? The W? The W is across from the X. Now, what does our similarity statement tell us should match up with the X? The N and the X should match up with each other, right? Because they both come first in our similarity statement. So the N and the X are matching up. So across from the N is the 5. You're right, it was the 5. W goes with the 5. And then I'm going to do 12. And the question is, what goes underneath the 12? Is it the 3 or the 4? Are you certain that it's the 3 and not the 4? Okay. Please don't make it be 3. Thanks. You're certain it's the 3 because why? Because they're the shortest sides, and you can see in the picture that they're the shortest sides? Okay. Again, that's going to work sometimes, and sometimes it's not. Your book is actually going to throw pictures at you where they will purposely stretch things out so that they're not the same. Like they'll show you a picture where it says 3 and 4, but the 3 is on the longer side. You got to go by the numbers, not by what it looks like. Okay. So I'm just warning you right now, you don't want to go based on the fact that in the book, it looks like the 3 is the shortest side and the 12 is the shortest side. You don't want to go by that. What you need to go by is the similarity statement. The 12 is across from the Y. And my similarity statement tells me that Y should match up with O. That's the middle one here, and O is the middle one here. So Y should match up with O. So O is right here, and 3 is across. So let's go ahead and cross multiply and solve. 3 times W is 3W. 5 times 12 is 60. Divide by 3 on both sides, and we've got our answer. All right, I really need you guys to practice either using the across from things, or I'm going to show you another way that you can do this, okay? So let me just show you something really quick. Thanks for your patience, guys. If I were going to put this on a test, this is what it would look like. X or Y, X, Z, P, and O. And you're going to eventually run into problems that look like this in your book also. You can't tell by looking at that which side's the biggest and which side's the smallest. And it will say on the test, figures are not to scale, which means you can't trust what it looks like. You've got to go based on the numbers, okay? So there's no way that you're going to be able to look at this and say that the 3 goes with the 12, because they're both going to look like equilateral triangles. Okay, so you've got to be able to use the information in the similarity statement. This one. All right, so here's another way that you can do this. I'm going to go ahead and this is my similarity statement. And see how it went NOP? I'm going to redraw my other triangle underneath it. And I'm going to relabel. This went NOP, right? So first, second, third. Here it went X, second, and then third. I'm going to make this second triangle match up with the first one. And then I'm going to go figure out where the W and the 12 end up. The W is between the Y and the Z. We want to make the W between the Y and the Z here. The 12 is between the X and the Z. X and Z is here, so the 12 would be there. Now it's a lot easier for me to see that the 3 matches up with the 12 and the 5 matches up with the W because they're orientated the same way. So do you see how you can use your similarity statement to redraw them so that they're matching? I really need you guys to be careful with this because this is where the mistakes happen in this test. All right, I want you to do one more for me. Part D. Go ahead and skip C. Do part D on your own right now. Make sure you're writing down the similarity statements because you need to use that to match everything up appropriately. And I would challenge you that when you draw these, just draw them as some equilateral looking triangles. This isn't exactly how it looks in the book, but eventually they're going to look like this. So when you set up your proportion, either make sure you're very careful about what's across from what, or take and redraw one of the triangles. If I were doing this problem, I would probably redraw this triangle underneath here, but I would make it match. This one, ABC, so ABC, so I would go XYZ. So I would draw it so that my similarity statement matched. And then make sure I get the M and the 11 in the right place over here, and then that would be easier. Go ahead and do that problem for me right now. When you're finished with that, you can start on the homework, which you guys already saw. We got a couple minutes left. Let's at least get the books open and look at the homework after doing this and see if you got questions. I need to check your checkpoint 8 while you're doing that. So if you've got that with you, get it out. If I don't get to you today to check your checkpoint 8, then evens, then we'll get you next time.